In this video, I'm going to talk about source transformation theorem. This is one of the easiest and simplest theorem compared to all other theorems. So here, source transformation theorem is simply if you have a voltage source in series with a resistor. So this is R ohm and a voltage source. We can convert this into a current source in parallel with resistor. So these are the AB terminals. So AB terminals are going to be the same. Now a voltage source is converted into current source, at the same time resistance value. Now the resistance value in both circuits, it's the same value, but this I value, I equal to V over R. And at the same time we can do the vice versa. If you have a current source in parallel with resistor, then we can convert that into a voltage source in series with resistor. Okay, so this is the basic knowledge you have to do the source transformation theorem. In the past, in my old classes, I saw a few students were doing this. If we have a voltage source in parallel with resistor, converting that into a current source in series with resistor. Okay, so this is not possible. If you have a voltage source in parallel with resistor, you cannot convert that into a current source in series with resistor. Only possibility is if you have voltage source in series with resistor, then you can convert that into a current source in parallel with resistor. Or if you have a current source in parallel with resistor, you can convert that into a voltage source in series with resistor. So here is an example. In this example, by using source transformation theorem, find power consumed in 1 ohm resistor. The 1 ohm resistor is right here. We need to find the power consumed by that. So all I need to know is find the current flowing through that resistor. Since I'm using source transformation theorem, I don't want to mess with this resistor. Keep this resistor as it is. Okay, keep the resistor as it is. Now when I look into the circuit, I see a negative 3 volts. I can convert that negative 3 volts into positive by changing the polarity of the voltage source. So I'm going to change the polarity here and make that as a plus 3 volt. So the polarity I have minus positive, and that's going to be 3 volt. Previously it was this is positive and this was negative and negative 3 volts, so I converted that into positive 3 volt. Now we are using the source transformation theorem. So now, as I mentioned, do not mess with this 1 ohm resistor, keep it as it is. I see a 6 ampere source in parallel with resistor. So I'm going to take these two terminals A and B, separate those two elements. So here is 3 ohm and 6 ampere. I'm going to convert this into a voltage source. When I convert this into a voltage source, make sure that the arrowhead is going to be positive. So I have arrowhead as positive, negative, and 3 ohms is in series with the source. It doesn't matter where do you connect that 3 ohms. Do you connect it to the branch A or branch B? It should be the same. So you can connect it to any one of those two branches. Okay, so now after converting it, I'm going to connect it back. So after converting it, I'm connecting it back. Here is my A, here is my B. Now these two resistors, resistors and the source, they are in series. What I can do, I'm going to, since those two are in series, I'm going to switch them. So here I have 3 volt and 3 ohm. I'm going to switch them, so 3 ohm and 3 volt, so it's not going to make any difference. So my circuit is going to be look like this. Now I can clearly see 6 and 3 ohm are in series and the voltage source is same, they're in series. So I will end up with here 3 plus 18. I'm adding them because they are seriously connected in additive mode. Sometimes you may end up batteries connecting like this, which is not recommended. to connect the batteries. So this is 18 volts, this is 3 volt, then we will subtract to get the remaining voltage. Okay, so now I end up with 21 volt 9 ohm. Okay, now again these two are a voltage source in series with resistor. I'm going to cut here X and Y, and I'm going to rejoin it back as a resistor in series with the current source. So here wherever you have positive, the positive is going to be the arrowhead. So the current is going to be 21 divided by 9, which is 2.33 amperes and 9 ohm. Now we can clearly see 9 ohm after conversion, okay, connected back at XY terminals. Now 9 and 2, they are in parallel. So 9 and 2 are in parallel. That value is 1.63 ohm. Now what we're going to do, I'm going to P and Q, cut the circuit right there. So I'm going to I have a current source in parallel with resistor. Okay, I'm going to label this as P and Q. Now I'm going to convert this into a voltage source in series with resistor. So this is 1.63 ohm, this is 2.33 ampere, this resistance is 1.63 ohm. Now my voltage is 3.8 volt. Okay, and P and Q. Now make sure you connect it back at the same nodes P and Q. Okay, now I have one loop. I can find the current. I just used applied the KVL in the loop, plus so I'm following this method, plus 3.8, 1.63 times I, 1I, minus 9 equal to 0. So end up with 2.63 I equal to 5.2, I equal to 1.97 ampere, P equal to V times I, or I square times R. I use the I square times R. End up with power conjugate by that is 3.88 watt. Thank you.